Hi guys, in this video we're going to be learning how to work out an unknown value using algebra. Now algebra is when we use letters in order to represent an unknown number. And our job in any algebra problem is to work out what that letter actually means. What is the numerical value? What number does that letter mean? So here we have the problem a plus 2 equals 5. Now a good way to think about algebra problems is like a set of scales. So we have a set of scales here and we've got an unknown bag of A. We don't know what's actually in that bag, so it's unknown at the moment. But we've got this unknown bag plus 2 extra marbles, and that weighs the same as 5 marbles. So at the moment, the scales are balanced. So whatever's in A plus 2 weighs the same or is equal to 5 marbles. Now I should say algebra isn't actually about weight, but it's just a nice way to think about it. It's a good way of thinking of a balanced set of scales is a good way of thinking about algebra. Now, we want to get just A on its own. We're wanting to find out what A is on its own. In order to do that, we're going to have to take away the 2 other things that are in A. So if we take off these from the scales, what's going to happen? Well, the scales are going to be unbalanced. This side is going to now weigh more, so this side is going to go down and that side is going to go up. So we know, because the scales are now unbalanced, the scales would be tipped like this, we know that A isn't equal to 5. Whatever is in this bag isn't 5 marbles. Because we took 2 out of this, to balance them again, we're going to also have to take 2 off of that. So we've taken the 2 marbles away, and what that will do is rebalance the scales. It will be balanced again. So we took the 2 marbles off the scales here, which unbalanced the scales. That meant we had to take these 2 marbles off this side here, and that then rebalanced the scales. So what we learned is that A, whatever is in this bag here, is equal to 3 marbles. Now, that's a way of thinking about it. How do we actually show our working? Well, what we have, we were given A plus 2 equals 5. Now we're wanting to get rid of this plus 2. That's the bit that we're wanting rid of because we want A on its own. So, in the next line, we're going to just have A on its own. How did we get A on its own? Well, we took off 2. That means that on the other side of the scales, we'll also need to take off 2 to keep it fair. So A plus 2 equals 5. That means that A equals 5 take away 2. Therefore, A equals 3. And that would be our answer. That's how we work it out. So let's look at a slightly more complicated example. We have our bag of A again, but it's A plus 17. So on this side of the scale, we've got A plus 17 there. And that is equal to 36. So on this side of the scales, we have 36. Now, we want to know what A is on its own. To work that out, we're going to have to take off that 17. So we've taken off the 17, and that is going to unbalance the scales. So the scales would now be tipped with this side being up and that side being down. To rebalance the scales, we're going to have to take this 36 and take 17 off of it. So what we've done is we're taking 17 away from this side, and to balance it, we're also going to have to take away 17 from that side. Now, that is a sum that you could easily do in your head, but if you were unsure, you could easily use any of your strategies to do it. So counting backwards, a chimney sum, whatever works for you. When we do that though, what we get is 19. So I've taken 17 off of the scales here. I've taken 17 off of this side here. And what I'm left with is 19. So in this situation, A equals 19. Now, here we should be starting to spot a bit of a rule. Whatever has been done to A, we need to undo it to get A on its own. So if A has had 17 added to it, in the next row we take off that 17. But because we've taken it off of one side, that would make the equation unbalanced. So we also have to take it off the other side as well. So what about this situation then? We've got A minus 10 equals 23. Now, in this case, we've got a bag of A. We don't know what A is, but we do know that 10 things have been taken out of it. So the bag has been opened and 10 has been taken out of it. 10 things have been taken away. We need to get A on its own. We want to find out what the whole of A is. To get A on its own then, we're going to need to add that 10 back in. We're going to have to put that 10 back in. So we're going to take that 10 and we're going to drop it back in where it belongs. But because we added on that 10 there, we're also going to have to add on 10 to the other side of the equation. Otherwise it wouldn't be balanced. So we've just added 10 onto this side, which is going to make this side heavier and that side lighter. So to balance the scales, we're going to have to add on 10 to that side. So A on its own equals 23 plus 10, which we should be able to work out quite easily. A equals 33. And again, using our strategy of before, we just cancel out whatever has been done to A here. So here they took off 10 from A, so we add it back on. But because we did it to one side, we also have to do it to the other side. So in this case, A equals 33. So now we have 3A in this problem. This problem here is 3A equals 18. Now we want to work out what just 1A is, but we've got 3 lots of it. This is a multiplication problem. It's written as 3A is 18, but another way you can think about it is 3 times A equals 18. You do not need the times sign in there, that is not necessary, but that's the way you should think about it. So A has been multiplied by 3. We need to undo that. How do we undo multiplication? Division. We're going to divide it by 3. But that means we're going to have to do the same to the other side. So to get A on its own, we're going to have to take those 3 A's and divide them. So we're going to end up getting rid of 2 of them. But because we did that, we're going to also have to do the same to the 18. So to get A on its own, we had to take 18 and we had to split it into 3 equal groups. We divided it by 3. So we're going to do our 3 times table up until we get to 18 and see how many stations that is. So we go 3, 6, 9, 12, 15, 18. That was a total of 6 stations. So 18 divided by 3 is 6. That means that A on its own is equal to 6 in this case. So we've done addition, we've done subtraction, we've done multiplication. The only other thing left to do is division. So here we have a quarter of A equals 5. Now you might see this written another couple of ways. It could also be A divided by 4 equals 5. Or it could be A over 4 equals 5. All of these mean exactly the same thing. They are all different ways of asking a division problem. So if you see it as a fraction, like either of these two, or you see it with a division sign in it, that lets you know that we are dividing in some way. So we have a quarter of a, or a divided by 4. And that equals 5. Now, if I've only got a tiny little quarter of a, I need to find a way of multiplying that in order to get the whole package, in order to get all of a. So if a has been split into 4 parts, if I have a fourth or a quarter of a, to undo that, I'm going to have to times it by 4. So to get a on its own, I'm going to have to times it by 4. But then I'll have to do that to the 5 also. I will have to multiply both sides by 4. So here, I've taken my quarter of a, and I've multiplied it by 4 to get the whole thing. But that means I'm also going to have to multiply the 5 by 4 in order to balance it, which means that a equals 5 times 4. Therefore, a equals 20. Now, obviously for a quarter, to undo a quarter of something, we times it by 4. If it had been divided by 5, I would have to times it by 5. If it had been divided by 100, I would have to times it by 100 in order to undo that. Okay then, one final challenge to finish us off. We have 7a plus 20 equals 55. Now, to start off with, we want to just get the a's on one side and the numbers on the other side. So to get the numbers off of the a side, I'm going to take away 20 to start with. So 7a plus 20 equals 55. I'm going to take away 20 from both sides, which on one side will leave me with just 7a, and the other side will leave me with 55 minus 20. That means that 7a is equal to 35. Okay, so 7 lots of a equals 35. But we want to know what just one a is. We want to know what a on its own is. Now, how do I get a on its own? I've got 7 of them. I want just one of them. Well, in that case, I need to divide it by 7. So to get a on its own, I'm going to have to divide by 7. But that means that I'm going to have to take that 35, so the answer to 55 minus 20, I'm going to have to take that as well, and also divide it by 7. So a equals 35 divided by 7. And if we know our 7 times table, we can do it all the way up to 35, and the answer we get is 5. So a in this situation equals 5. So what we've learned today is, in order to work out an unknown value, we need to, 1, keep the equation balanced. We must keep things balanced at all times, which means whatever we do to one side, we must do to the other side. 2, whatever has been done to your unknown value, you undo it. So if 20 has been added to it, you take away 20. If it's been times by 7, you divide it by 7. Looking at our previous examples, if it's been quartered, you times it by 4. If you've had something taken away from it, you add it back on. But you must do it to both sides. Cheers, guys!